A name to this structure right here. Two best tips I can give you that I also received when I was learning this was to read the formula backwards, read the name backwards, and the number of carbons in your name must match the carbons in the structure here. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons in our picture here. To write the name of this, we are going to write it backwards. The longest parent chain in this molecule is this cyclic ring right here. And this cyclic ring is 6 carbons. So we're going to call that cyclohexane. Now, it's cyclohexene, because it has a double bond within the ring. Now, we have to tell the reader where that double bond is. Now, because this is the parent chain, it is automatically called the 1 position. So if we count this, this has to be the 1 carbon right here. This cannot be the 1 carbon. I'll talk about that in a second here. But right now, this is the 1 carbon. It's the most interesting part of this molecule. It's got something else dangling off it here. This accounts for 6 of our 8 carbons. There are substituents on this cyclic ring, and there are 2 of them, and they are both methyls. So that's a dimethyl. Remember, di telling us there are 2 of these 1 carbon substituents. So di meaning 2, methyl meaning there are 2 that they are CH3s, and il tells us that it's a substituent or a pendant that's dangling off the parent chain. This accounts for 2 more of our carbons. So our name here so far has 8 carbons. We need to be able to give the reader a location of these substituents. Now, there's 2 ways we could count these, and I have the correct one here in green. 1, 2, 3. 1, 3 dimethyl. Now, there was another way we could have counted this. Let's say we called this the 1 position. And I'm going to show you, this is another way you could count it that's wrong. Okay. Now, if we had called this the 1 position, to count to these 2, we would have to go 1, 2, 3, 4, 5, 6. There would be a 2 and a 6 dimethyl. Now, what's wrong with this? These numbers are too high. It's just getting a little too complicated. Keep it simple. Keep the numbers low. Okay? If you can count it across the double bond and get a lower position of locants, that is going to be the more correct answer right there. Thank you.